All right, so we're chunking this out and kind of progressing as we go, trying to make progressively harder bodies to deal with. But we're really kind of like dancing around the same ideas. It's just Newton's second law and free body diagrams and how to kind of handle them. This guy here, we're still in one dimension. Now, if you're somebody who's fast and you want to zoom through this page and get, I don't know, 3, 4, 5, and actually this isn't 5 again, this is supposed to be 6. But if you want to zoom through these guys and beat me to it, do it. Treat it as a personal challenge. Try to have the correct notation and the whole thing. For those of you that need the refresher, then you're going to go along with me in real time, and that's totally fine, okay? All right, so I've got this free body diagram. Looks like I've got force 1, I've got the mass, the velocity is constant. So if the velocity is constant, what does that tell you about the acceleration? 0, yeah. So there's some implicit information there. The acceleration of the system is 0 meters per second squared. That's important. And we're supposed to find F2. So it looked like we had 2 unknowns, but actually we only have 1 because of the implied information. So then I say, okay, well, we're still going to deal with F net is equal to the mass of the system times the acceleration of the system. And we're trying to find F2. So I'm going to resist the temptation to get acceleration of the system isolated. I'm going to say, all right, F net is F2 plus F1 equals mass times acceleration of system. Remember, at this point, the only thing I don't know is F2. Something I know, though, is that the acceleration of the system is 0. So I could cancel out that acceleration of the system right now, but I think I'm going to hold myself back just for a second. I say force 2 is equal to mass times the acceleration of the system minus F1. And at this point, I'm ready to sub in. I could sub in the whole thing and say 5.0 kilograms times 0 meters per second squared minus F1, which was the 10.0 newtons. And I should have said this earlier, but I'm going to say it now. I'm going to have a reference frame again. I'll just preserve the previous reference frame. North, south, east, west. Positive for north, positive for east, negative for south, negative for west. And so when I subtract off that F1, it comes in as a positive value. Of course, anything with a 0 multiplies to 0. So F2 is just going to be negative 10.0 newtons, which is 10.0 newtons to the west. All right, we keep on going and actually bumping it up one level of complexity. So in the next level of complexity, I've got a 2-dimensional situation, finally to 2D. I've got force 1 and force 2. They appear to be going at right angles to each other, same reference frame, and we got to find the acceleration here. Well, if I'm going to do that, I know that acceleration, I'll just jump to the pre-isolated acceleration of the system is equal to F net over mass. The problem is I don't know what F net is. I can't just say 12 plus 10 is 22 because it's at right angles. I have to be a 2-dimensional thinker. So I could say, okay, well, F1 plus F2 is going to look like that. And F net is going to be the hypotenuse resultant of the sum of those 2 vectors added tip to tail. And we'd have an interior angle of theta telling us what direction that vector goes off at, right? And of course, we're going to use some Pythagorean theorem. So then we would say F net equals force 1 squared plus force 2 squared, all square rooted. And sub in our values. Looks like it was 10.0 newtons squared plus 12.0 newtons squared, all rooted. And can somebody help me out? I got 15.62 in my notes. Yeah, get the thumbs up. So 15.62 newtons. Notice that I'm going, really, my rule of thumb is that generally I'd like to go 2 extra digits in my internally unrounded values beyond what I know I'm going to have to round to in the end. So I've got 4 digits and I'm going to round to 2. So my internal unrounded values, I'm going to go a minimum of 2 extra digits. You can go 3 if you want to. It's great. Now in terms of the theta values, I'd say, okay, what do you like better, sine or tan or cos? What am I most confident about? tan, right? Because I know F1 and F2, opposite and adjacent. So I could say tan of theta is equal to the opposite, F2 over the adjacent F1. Notice that I'm not using op and adj. I'm using like the actual variables so that somebody could debug me if I make a mistake here. So tan inverse of F2 over F1, 12.0 newtons divided by 10.0 newtons. And again, I get a theta value of 50.2. Yeah? People with calculators? Okay. So 50.2 degrees. So then I go back and I say, okay, I think I got my leg work done. I've done the hard business. I can find my acceleration now. My F net, the magnitude, was 15.62 newtons. The mass was 5.0 kilograms. And 15.62 divided by 5, I know just eyeballing it, it's going to be in the neighborhood of 3. Again, my notes say 3.12. Does that sound about right to you folks? Okay. So 3.12 meters per second squared. And of course, I'm going to round that off to, if I have a direction, I'll apply the direction. 2 sig figs, because the 5.1 kilograms, is approximately 3.1 meters per second squared. And then directionally, I could say north 50, I'll put a line over the 0, degrees east. Or I could have said east, how many degrees north? 40, right? 40 degrees north. Or if I was really worried about scientific notation, I could have said east 4.0 times 10 to the power of 1. Probably would put this in brackets so it doesn't look like 10 to the power of 10 degrees north. But I honestly feel like if I'm handwriting things, I'd go with the middle option just because it's easier, you know? If I'm typing, I might feel committed to the bottom option. And you might see that in the answers at the end of a textbook or something like that, just like to take the ambiguity out of that 0, but it looks disgusting to me, you know? Especially with the degrees. All right, number 5. Actually, you know what? No, I do want to do it. I'm like so tempted to say, why don't you guys do it? And we'll like come back to it or something like that. How many people have already done number 5? How many people have already done number 6? All right, a couple people have already done number 6. So I need you guys to sort of, can you shout out answers as I go? And then we'll like make this go a little bit faster then, okay? All right, so I've got this free body diagram already laid out for me. The first thing that I might want to do is think about what's going on in the x and y directions independently. So I might say, okay, well, F net x is just going to be my F2 value. F net y is going to be, look, F1 plus F3. F1 plus F3, if I keep the same reference frame as I had up at the top left-hand corner of the page, that north positive, east positive, is going to be 10 newtons minus 4 newtons. 6 newtons. Now the reason that I would want to do that, somebody help me out. Why would I want to do that? Find F net x and F net y. Yeah? Yeah, once I got F net x and F net y, aren't I like right back up in question 4 territory here? I'm just kind of resetting it to make it easier on myself. Thanks, James. All right. So I say F net is equal to, and if you want to sketch for this, you totally can. You can say we've got the F net y. We've got the F net next, F net x, F net, and what we're trying to do is find the magnitude of the hypotenuse and the direction in which it's pointing. And so F net's going to be F net next squared plus fneti squared. And F2 was 12.0, 6.0. And somebody who's done this already, what's F net? Give me a nice healthy unrounded value.
13.4164.
Oh my gosh, that's too healthy. What is it? 13.41?
41640786.
I'm going to stop at the second 4. That's enough for me, okay? I'm already in too deep. All right, newtons. And then I'd say, all right, well, tan theta is going to be the opposite. Again, I like opposite. F next, or fneti. Theta is going to be tan inverse of next was the 12, and fneti was the 6.0. So somebody else help me out. What's the angle on this guy? 63 point what? 63.4. Okay. Sorry, I wasn't trying to be difficult. I just couldn't hear you over the air conditioning. That doesn't even work. It's just a fan. All right, so we got ourselves a direction. We've got ourselves an F net. And then again, if we wanted to find the acceleration, which I think is what we were trying to do here, then we'd say the acceleration is equal to the F net over m, which is the 4164 newtons divided by still 5.0 kilograms. So we're still going to round off to 2 sig figs in the end here. And I get 2.7. Is it 2.7? All right. So it's approximately 2.7 meters per second squared. And if I want to make this like an acceleration with a direction, then I could say, okay, north 63 degrees east, or east 27 degrees north, the bottom of which would be considered better according to our textbook. But either one I would be okay with. And now we end up at the last, and at least of this set, kind of like the climax question, where the climax question says, we have to tear this angled vector apart before we can put it back together again, right? And to tear it apart, what I mean is we'd want to find the x component and the y component of what we're calling F2 here, so that it would end up looking something like question 5, so that I could then take that question and make it more like question 4, so that I can solve this F net, right? So it's a little bit of backwards deconstructing before we reconstruct it into what we really want. And so this is the one where I want to pause. I want to actually hope that you guys can do this on your own. I'll give you the roadmap though. The first thing you're going to use is your trigonometry, your SOHCAHTOA, to get the x component of 2. So we call it F2x. That's going to use the cos ratio, because that x component would be the adjacent to this hypotenuse that you've been given. F2 cos theta. Then you're going to find F2y, which would be F2 times sine theta, because you'll be looking for the opposite to the given angle. Once you have F2x and F2y, you should be able to find F net x and F net y. Next is really just going to be F2x. Fneti is going to be F1 plus F2y, where F2y is going to be a negative value and F1 will be a positive value. Then once you have next and fneti, you're right back over to following the exact pattern of problem solving that's on the left-hand side here, okay? So I'm going to leave a few seconds. People that are in the classroom, I'm going to put the answers straight up on the screen. If you're trying to follow along because you're not here today, then you're going to pause the video, see if you can get it, and then check the answer in just a second, okay? So don't cheat yourself. So I'm going to put the answer up in 3, 2, 1. The answer, if we do everything correctly, should be 2.3 meters per second squared. And it'll either be east 21 degrees north or north 69 degrees east, depending on how you construct your right angle triangle. Just make sure that you can get to that stage, okay?